Welcome back to ACER Explained. In this video series, I'm going through Section 3 of the ACER Practice Test Booklet. In this video, I'm going through questions 51 to 52, so Unit 16. As usual, identifying prereq knowledge that you might need, reasoning skills, and the bootcamp resources that can help with this. So in this unit, we're given a big flow chart of the energy transfer during the oxidation of two molecules of ethanol and then also of glucose, and it leads to ATP formation. And so we're asked to answer the questions. It says specifically only answer them in relation to the information that's provided. So that's a key, that you should avoid using any preconceived notions that you already have about this topic. Okay, so now looking at question 51, it's asking which of the following, glucose, oxaloacetate, and NADH, if you labeled any of these three with carbon 13, would lead to carbon 13 labeled ATP. Now, carbon 13 labeling is something that people do in order to kind of track a particular molecule or a particular atom specifically. So especially with organic molecules, if it's tagged with your carbon, if it has carbon 13, you're able to track where that carbon is going to figure out exactly which atom is forming which molecule from start to finish in a reaction, right? So where is each atom that's forming the molecule coming from? So we want to figure out where are the molecules that are forming ATP, or where are the atoms that are forming ATP, where are they coming from? Now, if you look carefully, there are sort of a few stages of ATP production. Okay, there's one stage of ATP production quite high up, right next to that 1/2 glucose molecule, and there's an NAD plus to NADH conversion happening there, and you have the 2-ADP plus 2P that's leading to the formation of ATP. Then lower on, you have the same a similar thing happening with right next to your citrate and oxaloacetate. So this time you have you have the same thing, except this time you have 3 NAD, 3 NADH. Then you have 1 ADP, and you have ATP, 1 ATP plus 2 carbon dioxide. So that's your second one. Then finally, your final stage has this reaction here, 3 ADP plus 3P, and then you have your NADH to NAD plus. All right, and then you have your oxygen going into water, and then you have your 3 ATP being formed here. So what we want to figure out is, where is this ATP coming from? As we can see, it's always coming from these ADP molecules, right? And so we want to figure out, do any of these glucose, oxaloacetate, and NADH lead or contribute any atoms to the ADP molecules? And you'll find out that the answer is no. So there's no arrows that are going from either glucose, oxaloacetate, or NADH to those ADP or to those ATP. They're not going towards them. They're simply catalysts for this reaction sometimes. So NADH is a catalyst for this reaction here, and it's formed in this reaction here. It's a product of this reaction here. So it's not actually contributing to the actual molecular structure of ATP. And so the answer here is D. For this question, again, you didn't need any prerequisite knowledge. The carbon tagging is something that you can also infer, although it's a concept that does exist. It's something that you can infer. So if something is tagged with a particular molecule or an atom, and it's going through a particular reaction, then that's and it's asking you to kind of find something from the start and the end, then you can kind of infer that it's looking for what kind of molecule it's attached to and whether or not that molecule becomes a different molecule. So that's something that you can infer using reasoning. And then the reasoning skills used here are that pattern recognition reasoning skill, as well as being able to interpret that visual stimuli, that flow chart that we saw. So the bootcamp resources that can help with this are the reasoning skills course and the acceleration classes on introduction to reasoning, pattern recognition, and visual stimuli. Now, question 52 is asking us about how many moles of ethanol are needed to make the same amount of ATP that's produced when you have just 1 mole of glucose. So first we're going to look at that 1 mole of glucose. Let's see how much is actually produced by 1 mole of glucose, right? So in our diagram here, we're given the amount of ATP produced by 1/2 glucose. So half a mole of glucose. Okay, so when we're going through, let's go through that glucose pathway and see how much ATP is produced. So in that first step, where NAD plus is converted to NADH, you have 2 ADP that are converted into 2 ATP. So you have 2 ATP in that first step. Then your glucose turns into pyruvate. It also turns into acetate. Your acetate goes down into acetyl-CoA, and then across it goes into citrate. And then your citrate is converted into oxaloacetate. And in that reaction, you get your 3 NAD plus converted into 3 NADH, and you're also getting 1 ADP turning into 1 ATP. Okay. Then, finally, you have your 3 ADP plus 3P that's turning into 3 ATP using some oxygen and using all of that NADH as well that was produced in the previous bits of the reaction. And so you have 3 ATP being produced here. Okay. So, total for 1/2 of a glucose mole, you are getting 6 ATP. So 1 whole glucose mole will result in 12 ATP, so double that. Now looking at the ethanol pathway. In the ethanol pathway, you don't have that first step happening, but you do have the second and third steps happening. So with 1 mole of ethanol, you have 4 ATP. Alright, so now it's asking how many moles of ethanol are needed to make the same amount of ATP produced by 1 mole of glucose. So in order to create 4 ATPs, you're going to need, in order to create 12 ATPs, you're going to need to multiply this reaction by 3, because 4 times 3 is 12. So you're going to need 3 moles of ethanol. Okay, and so the only answer option here that fits is answer option C. So more than 2, but less than 4. And so that's your correct answer. So this is the same as before. You didn't need any previous knowledge. And in fact, you were discouraged from using any previous knowledge because, in fact, if you looked at the ATP production in real life, it would be quite different to what was shown in this diagram. So the ACER's kind of prepping you to use more of your reasoning skills compared to your prerequisite knowledge, right? So it's kind of a hint that in the actual GAMSAT, you're going to get more of these kinds of questions where you don't need that previous knowledge, and rather you're being asked to use the information that's provided to you and reason with it and try to find your patterns and try to be able to interpret the diagrams and various bits of information that they've given there. So the reasoning skills used are the same as before, your pattern recognition and being able to interpret visual stimuli. And so it's the same bootcamp resources that I mentioned for the previous question. And that brings us to the end of Unit 16. Please like, share, and subscribe for more GAMSAT help. We really appreciate your feedback. We have our Instagram at Thank Flip GAMSAT and our podcast, Thank Flip GAMSAT Nurses Doing GAMSAT, if you want to hear more from us. All right, I'll see you in the next one.